So section 5.5 is about use substitution. We tend to call it use sub, but it's use substitution. Hopefully you learned it in Calc 1, but it's probably the most vital tool we have. So we're going to refresh that concept now. The way you should do a video is to watch it and pause it and work through the math with me. Email me when you have questions, contact me, that's what I'm here for. I'm Professor Sandra Draper. Miss Draper is what I'm good with, and I'm going to start with number 8. You tend to have the odds in your homework, so I'm going to work through lots of the evens with you and teach you through the concept. So it says the integration of x squared e to the x to the third dx. Now, u sub is the integral form of chain rule. So what happens is that we can take the antiderivative of e to the x. So let's think about a little note here. Note. The antiderivative of e to the x with respect to x is e to the x. The problem comes in because there's more happening with this e right here. We need this just to be a single variable with nothing else happening. The composite function is what we see. So we're going to try to get it into the format to match this. We just have e to the x or e to the m or e to the something, but it's u sub, so we're going to use sub. And I'm going to take away this note because it's not part of the problem. So just remember that's our goal. Our goal is to get e to the x. Now we could have some constant out here, in which case we'd have a constant out here, and we always have plus c. So let me take that away and then we'll pick up again. So let's let u equal x to the third. It's that inside function of the composite function. So when we do, we're going to find the differential. So then du equals, and the derivative of x to the third is 3x squared dx. Don't get sloppy in your notation. This is what it should look like. Now, most people, when they do this, they solve for dx. So when we solve for dx, what we're going to do is divide this 3x squared to the other side. So we're going to put 1 over 3x squared over here with the du. Some people write the du on top. That's fine. I think it's easier to see this way. So then we have the integration of, we're going to keep the x squared. We keep the e, but we're going to put e to the u because that's what our u value is right there. Times 1 over 3x squared du. Now, paying attention to that, the x squareds are going to cancel, so that's going to work out well. And then we have the integration of 1/3. Now, the 1/3 is a constant, so it can go out front. E to the u du. And that's nice because that's what we can take the antiderivative of. Notice that in this line, the only variable here is u, and we have an e to the u. This line right here is a super important line. Once we've simplified it, there's only one variable. If you have more than one, then you've probably made a mistake. So let's continue. We have 1/3 the integration of e to the u du. So this is 1/3, and the integration of e to the u, the antiderivative, is e to the u plus c. So we did not start with the letter u. Go back to the problem. We didn't start with the letter u. We started with x's, so we need to reverse sub. So we're going to put an x to the third here, put the x values back in, plus c. That's our answer for number 8. Pause it, think about it before you continue to the next one. So let's look at number 10. Number 10 says the integration of the sine of t square root of 1 plus cosine t dt. That means we're integrating with respect to t. So the composite function is the square root with the stuff inside. The square root with 1 plus cosine t inside. So we're going to take the inside of that composite function. Let's go back to that real quick. We're going to take the inside of that and use it. 1 plus cosine t is our u. So let's let u equal 1 plus cosine t. Then du, the derivative of u is du, and the derivative of cos t is sine of t. The derivative of cosine of t is negative sine of t dt. So then solve for dt again, and dt is negative 1 over sine t, and then du. So we're going to take all of this value, this is our u, and we're going to see how this works out. So we have the integration of sine of t, square root of u. Now in place of dt, we're going to put du, which is negative 1 over sine of t du. Now you need parentheses around this. We didn't use parentheses last time, but we need them here because there's a negative inside. We need it to look like the multiplication of negative 1 over sine t and not that we're subtracting it. So we're going to pick up from here. I think we can cross off these sine of t's. So we have negative. That's a negative 1 left in parentheses, so I'm going to pull it out front as a constant. Negative integration. Now this says square root of u. That is the same thing as u to the 1/2. And u to the 1/2 is the form we need to integrate. So we're going to rewrite it as negative u to the 1/2. And then the antiderivative, we're going to bring down the negative because it's a constant. And the antiderivative of u to the 1/2, when we add 1 to the power, we get 3/2, and we do the reciprocal to be 2/3 plus c. Now, you can't leave u. We didn't start with u. So we have 1 plus cosine of t to the 3/2 plus c. Now 3/2 means 1 and 1/2. So we could write it negative 2, 1 plus cosine of t to the first, square root of 1 plus cosine of t plus c. In my humble opinion, I believe this is the best form. It's the simplified one, but you may use either. Take a minute and think about it, and then we'll move to number 12. Number 12, it says the integration of secant squared 2 theta d theta. Now the question often arises on this problem, what is my composite function? Because if you look at this, this could be written as secant 2 theta quantity squared. So secant 2 theta could be the composite function. But if you think about your derivatives that you know, the derivative of tangent is secant squared. So that antiderivative is really easy to find. So we're going to let u equal 2 theta. Because the antiderivative of secant squared of x is tangent of x. So we have to get a single variable in there with nothing happening to it. So then du equals 2 d theta. The derivative of u is du. The derivative of 2 theta is 2 d theta. So pause the video for a minute, work through it, and then come back and compare it step by step. So go ahead and hit pause and do the math. So I'm going to solve for d theta, and d theta equals 1/2 du. So we have the integration of secant squared u times d theta, which is 1/2 du. Now we put the secant squared u in parentheses because we don't want that 1/2 to end up on the u. That's going to take us in bad circles. It's not going to get us anywhere. The 1/2 is a constant, so let's pull it out front. 1/2 integration, secant squared u du. So we're going to bring down the 1/2 because it's a constant. And what is the antiderivative of secant squared? Tangent u plus c. So this is 1/2 tangent, and u is 2 theta plus c. Take a minute and think about it before you pause the video. Make sure that you agree. Maybe back up and work through it again, and then we'll move on. Okay, let's look at number 14. It says the integration of y squared times 4 minus y to the third to the 2/3 power with respect to y, dy. Take a minute, decide what y and dy are, solve it, set it up, and then come back. Pause. So let's let u equal 4 minus y to the third. Then du equals negative 3y squared dy. So solve for dy, which equals negative 1 over 3y squared du. So we have the integration of y squared times u to the 2/3 times negative 1 over 3y squared du. Notice the parentheses around the negative term, because it's all multiplication, it's all one term. The y squareds cancel. I have negative 1/3 integration u to the 2/3 du. Bring down the negative 1/3. To integrate, we add 1, so 3 over 3 plus 2 over 3 is 5 over 3. And then we multiply by the reciprocal, which is 3/5. Multiply by the reciprocal, the same thing as divide, plus c. So the 3's cancel, and we have negative 1/5, and u is 4 minus y to the third to the 5/3 power plus c. All right, number 16. Do number 16 and then come back to the video and do it with me. Number 16 says the integration of e to the negative 5r dr. Now you needed to do this without me, so if you have not, pause the video, do it, and then come back. Let's let u equal negative 5r. So then du is negative 5 dr. Solve for dr. It's negative 1/5 du. So we have the integration of e to the u times negative 1/5 du. So we're going to bring the negative 1/5 out front, e to the u du. And the integration of e to the u is e to the u. So we have negative 1/5 e, and then u is negative 5r plus c. Go ahead and do 18, and then come back to the video. That one's a little tricky. Often your u is what's on the bottom, but that doesn't make any sense here. So spend 5 or 10 minutes. Look at the video in pieces, and then come back to it. Number 18 says the integration of the sine square root of x over the square root of x dx. Pause, think about it, come back. So let's let u equal the square root of x, which is the same thing as x to the 1/2, right? So du is 1/2 x to the minus 1/2, which is 1 over 2 square root of x. Oh, there's a dx in there, dx. So let's solve this dx, and we end up with 2 square root of x times du. So we have the integration of the sine of u. Now we're tempted to put a u on the bottom, but don't do that. If your u went in both places, you still have a fraction, and there is no quotient rule. There is no quotient rule, there is no product rule, there is no chain rule. So the fraction doesn't help us. Let's leave that square root of x. And then let's think about what our du is. So in place of dx, we're putting, multiple dots, 2 times the square root of x du. See how nicely those square roots cancel? Let's pull the 2 to the front. 2 integration sine of u du. So 2 is a constant, so let's bring it down to the answer. Times, now the integration of sine of u is negative cosine of u. So negative cosine of u plus c. Now 2 times that gives me negative 2 cosine, and u is the square root of x plus c. You can skip this negative right here, but it is good math while we're on it. It is good math to have this line. You want to have the cleaned up line here. You want to have the antiderivative with u, and then you want to have the answer. So this is your answer at this point. Good math makes better math students. Number 20 is next. Go ahead and do it for a minute and then come back. Let me give you the problem. It says z squared over z to the third plus 1 dz. Now I'm often asked, can you switch variables? You can, but we get to the point where we're using lots of them. So it's better practice for you to go ahead and use the variables that are given to you. It's good practice for you. So let's let you should have worked on this by now. Let's let u equal z to the third plus 1. Then du equals 3z squared dz. How did you know that was your u? Often when something's on the bottom, that's going to be in the denominator, that's going to be your u. The things in the numerator hopefully will be taken care of, because when we go back, we can cancel things in the denominator because our du is often in the numerator or the denominator, and they cancel accordingly. So you got to pay attention to how those things work. But let's let you, if you play with it, if you let u equal z squared, if we let u equal z squared, then du is 2 dz, 2z dz. That didn't help us any at all, so this is not the right plan. We let u equal z to the third plus 1 like that, then our du is 3z squared, and you can see how that's going to divide to the other side and then cancel. So that's the way we want to go. It just takes practice to recognize what u is and to work with it. So then we're going to let dz equal 1 over 3 z squared du. So we have the integration of z squared over u times 1 over 3z squared du. The z squareds cancel. So we have a 1/3 over here. Let's pull that out front. 1/3 over 1 over u du. Don't write this part down. We're going to bring down, some students want to write this 1/3, the integration of u to the minus 1 du. So then it would be 1/3, and when you add 1, you get 0, and you can't divide by 0, so that's got to be a bad plan. Think about what you know. This form here, this form here does not help you. But if you think about 1 over u, natural log has a derivative of 1 over x. So the antiderivative of 1 over u is natural log. That's going to be our best choice. So this equals, it's the right answer, 1/3 natural log absolute value of u plus c. Do you know why it's absolute value? Let's plug this in. 1/3 natural log absolute value of z to the third plus 1 plus c. Do you know why it's absolute value? It's absolute value because the domain is from 0 not included to infinity. So you can't take the natural log of a negative number. And that was supposed when we did the antiderivative. So we have to include the absolute value bars. Number 22. The antiderivative of sine of x, sine of cosine of x, dx. Take a minute, pause the video, and come back. So we're going to let u equal cosine of x. So du would be, the derivative of cosine is negative sine of x dx. So we're going to solve for dx. So we have the integration of sine of x sine of u times negative 1 over sine x du. These sine x's cancel, so that takes care of the problem. In parentheses, we have a negative 1, which is a constant, so we're going to pull it out front. Negative integration sine of u du equals negative, and the integration of sine is negative cosine of u plus c. So this becomes cosine of x plus c. This is going to conclude the video for part A. We're going to look at a couple special cases, and then we're going to look at u sub with bounds. There's two ways to do it, and I'm happy with either. I will probably give you two choices for videos, so they will be up and ready for you very soon. Have a great day. Go do your homework for u sub, practice it. Email me if you have questions. Thank you.